All right, let's try this now. Class?
Yes.
Okay, that one's actually not bad. Not bad. The one this morning, my class earlier this morning, I don't know if it's just first hour, but yeah, they didn't feel it. They weren't feeling it. Had to try it a couple times. It still didn't work. But you guys are excited to be here, right?
Yes.
Yes. You're excited to get the answers to the test that you're going to pay attention to, right?
Yes.
Okay, good. That's what we're going for. So what pages in the notebook is this going to go?
26 and 27.
There you go. So 26 and 27 in my notebook. So right here it says a bag contains 7 red balls, 5 green balls, 4 yellow balls, and 2 black balls. A ball is picked at random from the bag. What is the probability the ball will be red? First thing, how much? How many are total?
18.
18, right? 18 in total. So I'm going to start with my fraction, 18 on the bottom. And what am I looking for? I'm looking for the red, right? So how many are red? What does it say?
7.
There we go. So that's the 7 red balls. So that's 7 over 18, which is going to give me 0.39. All right. So for this one here, try to just leave it as a decimal as often as can, okay? So I think there's like a multiple choice type thing that you're going to want to have the decimals only. Now, there's another way that you might see this, and this is actually in Mathanese. Like actual math language is going to be the probability of red. P of red. That's all that means. It means the same thing. So the probability of red. Next one, same question. What is the probability that the ball will be green or yellow? Or is my keyword. Okay? What does my keyword mean here? I'm going to add them together, right? I'm going to add them together. So the or keyword is adding. So again, how many balls are there?
18.
There's 18 to start off with. And my first one's going to be green. How many green do I have? 5. Plus, now my other one is going to be yellow. How many are there? Okay, there's 4 out of, there you go. And then we combine, and we're adding, since they already have common denominator, and I'm going to come up with 9 over 18, which gives me 0.50. So the Mathanese way is going to be probability P of green or yellow. There's a reason why I'm actually writing it in both ways, so you can see the language on this. When you see it, you can be like, oh yeah, that's what that means. All right, same question, but what is the probability that the ball will not be black? Will not be black. First, how many balls are there?
18.
There's 18. And how many are black?
2.
There's 2 black, and so therefore not black would be minus 2?
Wait, no, 16.
And it gets 16, right? It's going to be 16. Now, because I'm looking for the complement, it's going to look like this. It's probability of, let's say, black, like this. Remember this notation here? The complement means it is not that, right? So if not black. So if black was 2, everything else, so I take whatever that is and I subtract it from my total, right? And that's going to be the complement. So here, I'm going to get, what am I getting here? Does that make sense? Anyone questions? We good? I'm hoping. Total of 525 records of a hospital were reviewed, and 200 had heart problems, 175 respiratory, 100 had some type of trauma, and 50 had other issues. what is the probability of a randomly selected patient to have some type of trauma? Now, first, what is my total?
525.
It's 525, right? They give it to us in our first statement here. Total 525. So on the bottom it's 525. Now, I want the group that has some type of trauma. How many are in the group of some type of trauma? 100, right? So I'm going to put 100, which is going to give me 19.
Yep.
Questions, concerns, complaints, conspiracy theories? No? Okay. Ah! You saw that jump at me, right?
It attacked you.
I know, right?
Unprovoked.
I know. I was just sitting here and it came at me.
You should call the police.
Ugh. It's racist. It's a white box. Anyway, in a game, the spinner will land on yellow 25% of the time, blue 35% of the time, and red 40% of the time. If the spinner is spun 4 times, find the probability that all 4 spins are blue. Now, if I'm spinning this wheel of probability, is it going to change every time?
No.
Am I deducting anything? No, because I just spin the wheel and I'm not taking away any colors, right? I'm not taking away any colors. I'm not reducing the total values. So I'm looking for all 4 are blue. All 4 are blue. So first, what's it out of?
100.
100, because I'm dealing with percents, right? So it's out of 100, and blue is how much?
35.
So I have 35%. So 35%. So now that's my first spin. What about my second spin? Do I get the same thing? Same thing, because I'm not deducting anything. Because the wheel just spins. I just spin the wheel. I'm not taking anything off of it. So it's still 35 out of 100. Third one, 35 out of 100. And fourth one is 35 out of 100. Point what? 0.02?
Yeah.
I believe it's like 1.5, isn't it?
Is it?
Is it?
Yeah, it's 20.015.
1.5. Like that, right? So I'm okay with the 0.02, right? I'm okay with that, but, you know, get a couple numbers out there, because there might be a test question that is multiple choice that you need to match yours, right? And so you have to look at all the digits. Yeah? Okay, good. Good, good, good. So I'm trying to help you guys cheat. So some people are just taking a nap. All right. Now, question 6. Same question. This time, spinner spun 4 times, probability that none of the spins land on red. Okay. First, what's red?
40.
Red is 40%, right? But do I want red? No. No red, right? No red. So what am I looking for? What am I looking for now? The complement, right? The complement to my red is how much? Yep, 60%. So it's going to be 60% on my first spin to be not red. My next one is also 60%. And so all 4 of them are going to be like this, right? There you go. All 4 are going to be there. Yes? Okay. And what do we come up with? Point 0.13. You people agree? Disagree? Are you okay with this? Huh?
You get 60.
Where did I get 60? Okay, so it says right here, red. The probability of red is 40, right? Okay, red is 40. I don't want red. I want anything else but red. So if it's red is 40, the complement to that means everything else. So since I don't want the 40, so I take it away from my 100, because that's my total, and that's going to leave me with 60. So 60 is the complement. 60 is going to be all the ones that are not red. Because 60% of the rest is not red. Does that make better sense? All right. Good question, though. Numero 7. See? What I did there. Same spitter. Spun 4 times, probability that at least one spin lands on blue. Keyword is right there. What does that mean with that keyword? Or key phrase in this case? Something special. You know you guys actually have your notes, right? You know you have these things in your notas, in the nota book that is closed on your desk for some reason.
Your broom's back.
Did you go put the rocks back?
Yeah, there's no rocks in here.
There's no? Thank you.
Okay.
At least one is my keyword. What does that mean? So what do I start with if it's an at least one? 1 minus the probability. So it's going to be 1 minus the probability. But when I do this, which probability am I looking for? What probability do I plug in here? This was key. This is where a lot of people made a mistake when they're going over this. Do I want blue? No. I want not blue. That's how this works out here. That's the formula for this. So if you stood there, or right there, or you were sitting over there with your notebook closed because you had no clue how to do this, maybe some people might have put this in your notebook, which you could use on the examen. See what I did there? Examen. Write it down. I'm trying to help you here.
I'm doing that.
Yes, but there's other people not. They're just looking at me awkwardly. And there's a whole bunch of, notebooks that are like not being used or even closed or even not even out on their desks for some reason. But heaven forbid. Or just sleeping on their desk with their notebook open. It's all right. We just cleaned those desks right before this. It's all right. It's a nice, clean desk that you could drool on. All right, so we're going to do a probability of this. So the at least one does my formula like this. 1 minus. Now, probability of the complement to blue or not blue. So what's blue in the first place? 35%. So what's the complement to the 35? 65. So I take it away from 100, so it's going to be 65 over 100. And how many times am I spinning this? 4 times, so I keep doing it. Did you already write those? You already have those, right? Okay. Just making sure like the formula. You have the not formula. Okay. There's some, Alex, do you need some Visine or something? I think Kyrie has some Visine. You need some of that. No? Nothing? Like that? I want you to have some okay? So, like the formula for this. All right, what did we come up with?
90%, or
Point what?
9.8.
9.8.
That was 8 2.
Yeah.
99.
Oh my god.
Ah, give me. Ow. Ow. How'd you get .98? I think it might be times. That's what it looks like. There should be 1 minus all that. So don't make that same mistake next time.
80%?
.82, right?
Yes.
Oh.
Yes? Okay. All right, next one. Ocho. See what I did there? Ocho. All right, new 2020 car sold. Showed that 40% had sunroof, 29% had navigation, 25% had both. Draw a Venn diagram. And finish the rest of my credit card. There we go. Venn diagram here. Looks like this. I have 2 categories. So my first one's going to be 44%, and then next one over here is going to be 29. But what do they have in common?
25.
So 25% is in common, right? And now I got to try and figure out the back. You know, what the total is over here, right? So the math on this, if I was paying attention, is going to be 44 over 100 plus 29 over 100. And what am I subtracting? 25 over 100. Now, by doing this, this is what it gives me. It's going to give me everything that is in here. It's going to give me this percentage of everything in there. So that's everything on the inside. I still need to figure out all this out here, right? So what does all this right here have to add up to be? All of it adds up to 100, right? So when I did my math over here, I come up with 48.
Yeah.
Okay, 48 over 100. So that means on the inside circles together is 48 out of 100. So the complement, what I'm looking for, is the outside. So the outside is going to be how much? 52. So the outside is my complement of what I had on the inside. And again, they all have to add up to my total, which is my 100%. Questions? No? 9? All right. 120 people surveyed, asked type of vehicle they drive most often. A two-way table is created to show the data compiled. Probability of truck. P of truck. First, what's the total?
120.
And of truck. What's my total truck? Total truck is there, and my 120 is there. It's that easy. Do it.
0.35.
Do it. Point what?
35.
You people agree? All right, now, if you find this one in your notes, this one's one of the given problems. This is a given problem. So the formula looks like this. It is motorcycle and male divided by male. That's how I do this. This is how the formula breaks down. And when we were doing the notes on this, I said the first thing you need to do is start with the bottom of your fraction. So what's the total male? 62. So 62 goes on the bottom. 62 goes on the bottom. And now and is an intersection. So I have male and the intersection of male and motorcycle So the intersection, that's the and right there, is going to be the 8. Because that's it, the only number that's in both. And when I do my math, I come up with point what?
1, 2.
All right. Questions, concerns, complaints? We still good? So I know you guys make sure you find these and have these in your notes, okay? Because these are important. 11. Okay, so
So we can have nice
time pick it up. That's why you can't have nice things.
Well, that was good.
Uh-huh, yeah.
Man.
Can't believe these people. Anyway, soccer team shirts have arrived in a big box. The box contains 4 medium, 10 large, and 6 extra large shirts. You want a medium for you and your sister. Find the probability that the first medium shirt you find is the third shirt you pick. First, how many shirts are there? 20. We get that by?
I don't know.
Just add them all up. So I get 20 shirts. Now, on my first pick, I'm reaching in. Am I going to get a medium? No. So how many mediums are there in the first place? 4. Okay, there's 4 mediums in the first place. So that means that the complement, everything else is not medium, isn't it? So what's going to be the complement? 16, right? 16 is going to be the complement because all those are my not mediums. So I go 16 right here. Now, what am I going to do with that shirt? I'm going to take that shirt and be like, this is not the right size. Am I going to put it back in there? No. I'm going to set it over here. Bam. I set it over there. Is that still in the box? No. So how many shirts are now in the box?
15. Oh, 19.
Yeah, 19 in the box total. And now this time, I reach in again. And again I get not a medium. So it's not going to be a medium yet. So I reach in, and so what is the not medium? 15. 15, because there's 15 not mediums left in that box, right? Does that make sense? Okay. So I take my shirt, and right over here, bam, is that still in the box? Nope. So I'm reaching in again. Now, how many total shirts are in the box? 18, because I took out
Another one.
2 shirts, right? But this time, my third shirt is a medium. My third shirt is a medium. So how many mediums are there now? There's still that 4 mediums, right? Because none of them that I picked were medium. So there's going to be 4 out of 18. Yep. So that's how long it took me to get the first medium. So calculate, por favor. Point what? Okay. Yes? No? Maybe?
Yeah.
Hopefully. Alrighty. This next one. Ooh, put my shirts back. Put the shirts back in the box. There we go. Shirts are now back in the box. For those people following along at home, I have a pile of papers I'm pretending are shirts. So the soccer team, again, same problem, but this time, probability that the first 4 shirts you pick are all extra large. How many total are in the box?
20.
20. There's 20 in the box, right? The first one that I'm going to get is a what?
Extra large.
Extra large. How many extra larges are there?
6.
There's 6 extra larges. Now, I'm taking my extra large. Be like, oh, hey. My extra large. I'm taking that. It is now over there. So how many extra larges are now in the box? And how many total shirts are now in the box?
19.
There we go. All right, so I just took out another shirt, isn't it? My second extra large just came out, and it's now going over here. So now, how many extra larges are left in the box?
4.
4 extra larges are left in the box. But now, how many total shirts are now in the box? 18. So I'm taking this shirt right here. Bam! It is now going over there. So on my fourth shirt, how many extra larges are in there now? 3 out of how many shirts total?
17.
There we go. And go ahead, plug those into your handy dandy calculator. And what do we get?
0.003.
Like that? Yes? No? Maybe? Hopefully? All right. Okay, that's good. 13. Says a 12-pack of Pepsi. How many Pepsis are in the box?
12.
Okay. I was dumbfounded because someone told me something else when I was going over this. So, 12-pack of Pepsi, there is how many in there?
12.
There's 12. 4 of the cans have a special code to earn online contest for a prize. Okay. So if 4 of them have a code to earn the special prize, how many are not special? 8. 8 are not special. How many total is there?
8 over 12.
Yes. So it's going to be 8 over 12, right? So I heard a 16 from somewhere way back there. Yeah. And so when I said there's only 12, can't have more than that. Okay, 3 cans, none of them have special codes. So it's going to be an 8 out of 12 the first time. And watch this, watch. Okay? After this class, this is me right here. I'm grabbing my Pepsi. Wait, hold on.
Are you mixing it in there?
I'm not implying that I had to mix something in there. But then I just, right there, I'm done. It's going in the trash. All right? So how many are now left? There's 11 cans left now, right? Okay. So now the next pick is going to be out of 11. But on this next time, is it a special can?
No.
No. If it's not a special can, how many of those are left?
7.
There's 7 not specials left. Okay, watch here. Here I go again. Watch right here. Especially after this class. Watch. Okay. Okay. And wait, hold on. Wait. Look. Look. Can goes in the trash right there, right?
No ice.
Huh?
No ice.
After this class, you would be like, yeah, it doesn't even matter.
No,
It just needs to, yeah.
No salt on the
Yeah,
rim.
yeah.
No salt on the rim, no lemon.
Seriously, how will you put salt on the rim of your Pepsi? How dare you? What's up, my home?
You scratched me.
Huh?
You scratched me.
Oh, you know what they say, right?
I don't care.
If I, you can scratch my back, I scratch yours. Isn't that how it goes? I just got weird, right? Okay, this is the review that we were doing just Tuesday.
Okay.
So if you already have it done, then we're finishing it up, okay? All right, so since Fabiola likes putting salt on the rim of her Pepsi for some reason, okay, we're picking another can, right? But now, after Fabiola finishes her soda, all right, now, what are we going to have on the bottom? How many cans are left?
10.
There's now 10 cans left, right? And
6.
there is still a not special, right? So there is going to be 6 not specials left. And that's all 3, right? Multiply them out. Point what?
2.5.
You're on a roll.
I know, right? See, I don't know, I get distracted by someone coming in here. Anyway. Alright, question 14. The bag contains 7 red chips, 3 blue chips, 6 green chips, 3 chips are drawn at random and not replaced. Okay, you ready? There's probably like, yeah, that many chips in there. Alright, how many chips total are in there?
16.
Okay, there's 16 chips left in here, alright? Okay, 16 chips left in here. So, now, oh wait, hold on. Let me do this. Let me do it right here. Now, says 3 chips drawn at random. What's the probability that at least one of the chips is blue? Because this is the 1 minus, isn't it? Hey. This is the 1 minus problem, isn't it?
Yeah.
Yes, my key phrase is at least 1, isn't it?
Yeah.
Key phrase is at least 1, so I start with my 1 minus. So it is my 1 minus. Now, when we do these problems right here, it says 1 is blue. But do I want the blue chips? Say no. No, we want the complement. So how many blue chips are there?
3.
There is 3 blue chips. What's the complement to that 3? 13. Because we took our blue chips, right? And took them away from my total. So there's going to be 13 there.
And we took an L.
All right? Now, you ready? You ready? So my probability, I just reach in there, grab one, bam. Not blue, right?
Yeah.
Okay, so, all right, are you ready? Now, how many chips are left?
12 over 15.
There's 12 not blues out of, thank you. And my third, drawn 3 chips, right? So, in here we're going, yeah. All right, my third, how many not blues are in there? How many not blues?
11.
Out of?
14.
Yep.
Uh-oh.
What the deuce?
It's because I got here.
Yes! Okay, there you go. There you go. 11 out of 14. All right, thank you. So, go ahead, put that in tu calculadora, por favor. Point what?
4, 9. You round it.
I don't know.
Oh, I'm showing.
I don't know.
I'm showing.
Yeah. 0.49. Yeah. All right, there we go. Again, with that key word, you got to make sure you're listening for those key words or reading through those key words so that at least one is the one that's going to identify that, right? All right, let's go. 15. You're dealt 4 cards from a standard 52 card deck. Was the probability that you get no kings? Now, I didn't realize this, that a lot of people have no clue about a deck of cards.
Yeah, we're not.
How many kings are in a deck?
4.
There's 4 kings in a deck. How many 2s are in a deck?
4. 4 and
How many jacks are in a deck?
4.
There's 1 of every suit. 2 of hearts, 2 of clubs, 2 of diamonds, 2 of spades. Okay, so there's 4 kings, right?
Yes.
Now, watch this. This is another way of writing this. So I'm looking for the probability of not kings, right? And what's that? Complement. And the complement. So, how many kings were there?
4.
4. So the complement to 4 would be 48 out of 52. There we go. All right, how many of these do we have? We're getting dealt how many cards? 4 cards. So let's do it again. But now, since I just dealt you a card that was not a king, how many not kings are left? 47. And what's the total?
51.
47. Well, I don't know why. The next one's going to be 46 out of 50. And my fourth card is,
49.
there we go.
And just put it in the calculator.
Yes. Put it into calculadora, por favor. Por favor. Candy, por favor to calculator.
It's not working.
Why? Because, you know, that's your phone, not your calculator.
And I
Did you
need-
try and talk to it nicely?
And I need the from Tuesday and
It's the same as what we did on Monday. Did you do the ID assignment?
I don't remember.
Someone was at work that day.
When?
Monday. No? Anyway, all right. What do we get here? 7-2? There we go. Sidewalk. Ice cream vendor sells average 65 ice cream cones per day in warm weather, average of 15 cones per day in cold weather. If the weather in this area is cold 25% of the time, determine the expected number of ice cream cones sold per day. So what we're going to do is we're trying to average this out. So on a cold day, we know it's 25% of the time. So I want to write that as a fraction. How would I write that? 25 over 100, right?
Yes, that's what I definitely said.
25. Now, what is the complement to that 25%? 75. So that's what I'm going to be looking for. So 75 is a good day, right? So 75% of the time, it's a good day. And on a good day, what do I get on a good day?
65.
I get 65. But on a bad day, I get what?
15.
I get 15, don't I? So that's a bad day. So it's, I'm going to put that in there because it's not a good one, right? So when I do this, it's averaging it out, even though it looks like it's like charging me here, but I'm averaging it out per day. Because according to this, 1 out of every 4 days is a bad day. Right? That's 25%. And what do we come up with? So how many ice cream cones should we sell on average per day?
45.
39?
39.
39? I don't know.
Let me see.
Someone else, 39?
Yeah, she got 45.
35.
Who got 39? Let me see. Can I see your calculator? Oh. Anyone else? Do you have it on the calculator? Yours says 65. That's why. It should be 25. Okay. So 45 is it. So 45 is it. All right, you got to be careful. Got to double check your work, right? So 45, on average, I should sell about 45 ice cream cones per day. As long as I'm not on my phone, I might actually get something done per day. Don't you hold up me. Don't you. I'm about ready to lose it. At a community fundraising event, Anastasia buys a ticket for the $100 door prize. The cost of the ticket's $5, and 500 tickets are sold, determining Anastasia's expectation when she purchases one ticket. Now, how many chances does she have for this?
One.
Out of?
500.
1 out of 500. So there's my probability. What does she win?
$100.
$100. Now, I call this the Fred. It's all the other ones that are against you.
499.
You have 499 Freds. So you have your one chance, and all the rest of them are Freds. So there's 499 preying on your demise. Out of?
500.
And what do you lose in that one?
$5.
You lose $5.
Have you watched Smiling Friends?
Who?
Smiling Friends.
No.
You're the second person who's talked about that show.
No.
It's a really good
Hey,
show.
hey, no. No. Put in your calculator!
I did.
What'd you get?
Negative 4.79.
Good job! Okay, so we get negative 4.79. Yes? Okay, negative 4.79. So that means that I'm expected to lose money every time, right?
Yeah.
That's not a good thing. It's not a good thing. But now on question 18, if you looked at the notes, we have fair price is equal to my expected plus cost. Fair price is always the expected plus the cost. So this came from my previous problem. What was my expected outcome on that previous thing?
Negative 4.79.
There we go. So it's negative 4.79. And how much did it cost me to play? $5, right? And so what do we come up with for our fair price? Is 0.21. So the fair price is when it will break even. So at the cost that neither I lose or the other people lose. Does that make sense? Nonsense? All right, make sure you like, share, subscribe, hit that notification button. And yeah.
It's the brown.
Yeah, then catch me outside. How about that?